All right, yeah, sounds work. Great. All right, so good morning, everybody. Thank you for joining the session. Originally called The Future of Cloud. So I was just thinking, although we actually sell crystal balls in the Amazon store, we do not use them to predict anything like the future, right? So this session is actually more about trends in computing, trends in cloud computing that we see. And that's what I'll be covering actually in this session. So for the people coming in, there's still plenty of seats here in the front. So yeah, we have these pillars in between us sometimes, so I'll just move around a bit to have a bit of contact. So just a quick introduction. My name is Matthijs van Zeldam. I'm a solutions architect for Amazon Web Services in the Netherlands. In case people were wondering, we are in the Netherlands. My role is actually to enable partners, technology partners, and consulting partners on the AWS platform. So, trends in cloud computing, actually. So, what are they, and what do we actually see? So, one thing is that cloud becoming the new normal. You probably read about it, heard about it, but we actually see this happening more and more. Actually, last year, I think this is sort of becoming a standard behavior within organizations to deploy new applications into the cloud and actually also quickly migrate existing applications in the cloud. So that's the whole thing about cloud first strategy, basically. So cloud computing by itself, I mean, a lot of people have different definitions for that. And so what is actually cloud computing? So I always like to show sort of what we think that true cloud computing is. So it's the on-demand delivery, right? The on-demand delivery of scalable IT resources. And the on-demand aspect is very important for agility, for speed of innovation. Like if you attended the keynote from Mendix this morning, it's all about speed, right? So the on-demand aspect is very important. Having scalable resources to you is very important as well. And another thing that a lot of organizations definitely like is to have zero upfront costs. So you don't pay anything until you start actually consuming services. There are no long-term contracts, there are no long-term commitments. You can stop at any time, so you'll stop paying any time. And there is pay-as-you-go pricing model in there. So these characteristics of cloud computing lead actually to the main benefits, so to speak. So the main reasons organizations adopt cloud computing. And so specifically, why do they select the AWS cloud? Number one actually is agility. So agility enabling organizations to really move fast. So go fast to market, for example, to design, develop, and deploy new solutions much faster than they were able to do before. Another one is cost savings. You can considerably save costs by deploying your solutions in the cloud compared to hosted or on-premises solutions. So that's number two. This is really an ordered list. So elasticity is another one. So you can deploy your solutions, you can scale up, you can scale out. When necessary, you can also scale in. So that's the whole elasticity aspect actually of it. Another one for the AWS cloud is basically the breadth of its functionality. We have a lot of services. Also the breadth of each of the services is pretty extensive. And that's one of the reasons why customers select AWS cloud. Another one is global reach. So it's so simple today for organizations to deploy their solution on a global scale. And I have several examples of that coming up. So what does set AWS apart? So we've been in this business for at least 10 years, actually more than 10 years. So we have a lot of experience in that. So it basically comes down to outstanding operational performance, for example. Like I mentioned about the services, we have many of them, but I'll go into a specific slide about that. We are well known for our pace of innovation. So we innovate. We do that very quickly. We release more services and features every year. So last year we released over 722 new services and features. So all the innovation is actually driven by customer demand. 95% approximately of our roadmap is driven by customer feedback. So that's an important thing as well. So customers are really aligned to what's happening in our cloud, and that we are actually serving their needs. So like I mentioned, we have a global footprint. I'll go into that in a bit. We have proactively reduced the prices 51 times year to date, actually. So based on operational efficiency, if that leads to cost savings, we'll definitely basically reduce our prices for our customers to benefit of the cost savings as well. And we have a very, very large ecosystem. So we have a huge partner ecosystem. We also have a lot of users, so a lot of customers as well. So what is the AWS cloud? Just if you're not familiar with what AWS actually is, I already spoke yesterday with a couple of people who are completely new actually to the AWS cloud. So what is the AWS cloud? So it's our global infrastructure of data centers of which we deliver our cloud services. That's basically what it is. And we exist in North America, South America, in Europe, in Asia, and in Australia. We have these concepts of regions, availability zones, and edge locations, and some of them are pretty technical, so I'll not go into those. But the region is an important concept because it really determines where the applications are being hosted and where the data is being stored. So customers select a region based on the location, based on their location, or which one is closest, or which one are closest to their users. We are currently at 12 regions. We announced some others as well, 5 new ones to come online this year or early next year, and one of, for example, for Europe, which is important, is in the UK. So the 3rd European region will be in the UK. So we are proud to serve over 1 million active customers. We like to refer to our customers being on our platform as being active. I mean, there are a lot of subscriptions with many providers, but we really have a lot of active users running every imaginable use case. So we have customers of all segments. There are no segments that we do not have customers of in our AWS cloud. And you may recognize a couple of the icons here, a couple of the brands. Obviously, there are not 1 million in this slide, but you'll see some major brands, enterprises, startups, well-known players like Netflix or Spotify or WeTransfer here in the Netherlands or Philips. Many actually of the quite popular consumer applications are being hosted on AWS as well. So it's not only commercial organizations, it's not only retail, manufacturing, financial industry, healthcare, but a lot of government as well, which is quite impressive. So it could be governmental, it could be educational institutions or non-profit organizations. Like I mentioned, we basically have customers of all segments. So what comes from this AWS cloud, this global infrastructure? So it's hosting our web services, obviously. So what does this look like? So I have a sort of categorized view of what we offer from the AWS cloud. So obviously we have this global infrastructure, the data centers, the facilities, the regions. On top of that, we offer our core services, our foundational services. So think of compute services, services for storage, services for networking, for databases, managed databases, which are sort of the foundational in many applications. On top of that, we have a very broad suite of security services. And although they are sort of plotted here separately, security is typically something that is job zero at Amazon. So security is embedded in everything. So in every service, everything is embedded when it comes to security. So on top of that, you'll see a lot of, I would like to call them building blocks. So services that you can use in your application without having to develop them yourself. All right? So services for big data, services for analytics, services for workflow, services for mobile app development, and the whole infrastructure basically behind mobile apps. These are just building blocks that you can add to your application, because you are not differentiating your application by developing, for example, your own email solution. That's just a feature, just a function that you can add to your solution. So we have services as well for DevOps, Obviously, you want to be able to also monitor, manage, and operate the whole environment, not just host your solution, but you also want to know what's going on. So that's important as well. From the keynote, you probably understood that we have complete services like IoT, an IoT service, which also takes the heavy lifting out of your solution in, for example, the whole data ingestion coming from all your devices or setting properties on your devices. That's all being taken care of for you, so you can, again, focus on the application. We also developed enterprise applications, also based on demand from enterprise customers to offer specific features that they've been asking for and that they want to consume in the Amazon way, like pay-as-you-go. On top of that, we have a marketplace. Like I mentioned, we have a large partner ecosystem. So in the marketplace is where you will actually find all the technical solutions that ISVs, our technology partners, have developed on top of the platform. So that's a big one as well. Obviously, when customers migrate into the cloud, they're already in a hybrid IT, like we call them. So in a hybrid IT scenario, where it's important to support a hybrid scenario while they're migrating into the cloud. So we have a lot of services there as well. So just going into the marketplace specifically, also important into the context of Mendix World, the marketplace makes it very easy for you to find solutions. For example, like the one from Mendix. So we have over 900 software solutions in there, so from third parties, adding value to the platform. There's over 2,600 product listings, and for you, it's very easy to find the solution, so to discover them, but also to deploy them. It's basically maybe you're familiar with the one-click deployment, one-click procurement. We already negotiated the whole licensing with the third-party vendor, so you consume these products on the same way that you do AWS services. So pay as you go, monthly billing. If you want to stop with a product, you just stop and you stop paying as well. So it's really easy also from a procurement perspective. So specifically, I just put some screenshots in here. When you search for Mendix, you will find a lot of the Mendix solutions in the AWS Marketplace. And indeed, you select where you want to run your Mendix workload, which runs in your AWS subscription in this case, and it's going to be deployed according to the best practices, always from the technology vendor. So I just edited this one because I was sitting at the keynote, so I knew there's a lot of integration from the Mendix platform with AWS. I also attended the hackathon on Monday, so people were actively using IoT and things like Redshift, our data warehouse solution. So I think the important message from as of this morning is more that there is out-of-the-box integration with AWS, but if you want more integration, then you can, for example, use the connector kit that was announced and just add more to your modeler. So really powerful, I think, really powerful feature. So just a couple of scenarios reflecting back to the benefits of cloud computing. So the key things like, for example, agility. There's a very interesting case with BMW that's actually has developed a solution to leverage their cars being sensors. So it's a very interesting development to see that a car manufacturer of premium cars thinks about what they can add to their customers, added value on top of just the car. So they developed a solution to add dynamic information to their map, the map information that is available in their cars. And it's really opened up a lot of possibilities for BMW as well. So BMW, obviously, as a car manufacturer, there are cars driving around. And they were thinking, so what can we do with the fact that our cars are driving around? That's really that simple as it is. They said, well, we can actually get information from the cars while they're driving around. And so they developed this solution. And again, being agile, they tested things out in a very short period of time. And the whole solution was developed in 6 months. And they called it the Carrasso, the car as a sensor. It applies to the BMW 7 Series. I don't know if anyone is driving a 7 Series here, but then you're maybe lucky. It will probably go to other car models as well, but that's where they started. So going global, for example, like I mentioned, very easy to go global. Think of Airbnb. I just guessed that a lot of people here are at least familiar with Airbnb. Maybe you have already booked your vacation. I booked a castle in Ireland, for example, using Airbnb. So it enables every one of us, actually, to rent out your property, right? If you have a castle, if you have just your house or a cottage or anything, then you can basically put that into Airbnb and people can rent it, right? And so this started in 2008, more in the time that the economy was a bit of less optimal, let's say that way, on a global scale, and it became immensely popular. People thought, yeah, I can make some extra money by renting out my property, my house, or indeed my cottage. And so it grew from thousands of users to millions of users. They have over 50 million property owners currently in their solution. And so it was very easy to go global to basically deploy their web app, their web solution on a global scale. They still do this with a handful of people. They're still at 5 from the operations perspective. So it doesn't really matter to them whether it's an application being used by hundreds of thousands of users or millions of users. And that's really, really interesting case as well. A very recent one, I just picked this up because I just picked it up actually on the Twitter feed as well. So the Endemol one, I think following my presentation, there's an Endemol presentation on their success and saving costs by going into AWS. This is actually a sort of combination. So Endemol is used in AWS, but Endemol is also using Mendix. So although I do not really know all the details, I would have to attend that session. I just picked up the key things that came out of an interview with Endemol. It's that they saved approximately 70% in ICT investments and 30% on the operational side. So when it comes to cost savings, we also have very interesting local as in Dutch companies achieving these. So switch to another trend, security. Security always comes up when it comes to cloud, at least definitely 5 years ago. I mean, when I went into partners, for me it was partners, and they always talked about security. Security always comes up, and actually security should always come up in any solution. But anyway, I think 5 years ago, sort of security, cloud security was the argument to not go into the cloud because it was more or less a trust issue. People thought, well, sort of cloud is internet, and internet is not safe. Think of Prism and Snowden and all the other developments, so it could not be secure. So we operate a shared responsibility model with our customers. That's one thing. You will find it in all our documentation. It has been adopted by many of the other cloud service providers out there as well, which means that we are responsible for the things that we are in control of. So things we have control over, like the data centers, the facilities, the networking, everything we operate, that's where we are responsible of. But customers are responsible of basically how they use the cloud. So although they are not in control anymore of the physical infrastructure, because it's typically when you move to the cloud, they are still in control of their data and their applications, and still up to the user, the customer, to protect the data. So to apply filtering, for example, in a network, so firewall rules, to encrypt the data, if they wish to do that. It's still all up to the customer. That's not up to us. They can choose to do so. They can choose to open everything up. And so the scope of responsibility also really depends on what service the customer is using. So if they use virtual machines, then they have full control over machine, they have full control of the operating system, and everything they put in the operating system. If they decide to go for more containerized services, like managed databases, then they don't have to manage the operating system anymore. They don't have to manage the database even anymore. So the scope can be as broad or as small, but it definitely starts on top of what we have control of. This secured, or this shared responsibility model, this also applies to compliance, which is also very important. There, you will probably have compliance discussions. If you are in a regulated industry, then you may need to comply with certain standards. So, because it's a shared responsibility, you cannot be fully compliant, for example, for PCI, just by pointing to the fact that we are compliant for PCI. We can only be compliant for PCI, again, for what we have control over. And so an auditor will request our compliance reports, which are available, and then they will assess the compliance of the customer in the cloud. And then together, they may be certified as PCI compliant. So just for example, we have many of them active in the financial industry. So when someone is processing credit card information, they need to comply with the payment card industry standard. And so together, so their certification and our certification together enables customers to be compliant. I mentioned that 5 years ago, definitely, when it came to cloud, there was a shift. Or there was definitely, the discussion was different, let's say it that way. Discussion were different than today. So 5 years ago, usually, when it came up with cloud, and a lot of people, a lot of customers, partners would say that to me as well, there's a lot of objection to going into the cloud because it's not secure. Not quite often based on really any true arguments, but still, it was also a trust thing. So I just picked up a couple of the statements of analysts, and this one from Forrester comes from 2013, so 3 years ago, where Forrester actually reported that they saw organizations adopt cloud computing for the improved security. So it became actually very interesting that you got a shift there. It did not stay there. So last year, so 2015, IDC came out and made a statement in their report as a summary that you can be more secure in the cloud than in your own data center. That's a pretty firm statement. And so it was a confirmation to me that, yeah, there's really, things are really changing. I experienced that as well. And then Gartner came along, and Gartner came out with a report in September, I believe, where Gartner made this statement, clouds are secure. Are you using them securely? So they really shift the whole discussion around. They say, we're not going to talk about cloud security, specifically if it applies to cloud service providers. So we are not going to discuss the security of cloud service providers. These guys are secure. You cannot come even close to their level of security in your own environment. The whole issue is, the whole topic is, are you using them securely? So I'd like to link this back again to the shared responsibility model. It all depends on how you implement your applications, how you secure your data in the AWS cloud. And so leverage all the features that we offer to be secure and compliant. So we always like to refer to customer testimonials. So here's another quote, in this case from the CTO of NASA, of the Jet Propulsion Laboratory, basically making that statement that they believe that they can be more secure in the AWS cloud than in their own data center. I think it has some weight because NASA is definitely a security-minded and security-conscious organization. So making that statement is pretty strong, I think. Another one comes from the financial industry, like Capital One, the Capital One Bank, making the statement that, yeah, they believe they can operate in a more secure way in the public cloud, referring to AWS, than in their own data center. So there's a lot of evidence today, and that's something I experienced as well, talking to my partners that actually then talk to their customers, that there is definitely a change going on in the whole perception around security and cloud. One thing I definitely like to stress is we always say you should always have a security discussion. Security should not be something that comes in the end. So security should be there with anything you do into cloud right from the start. Right from the beginning, you should involve security and get there basically their approval for anything you do in the cloud, and they'll make sure that it is compliant and it is secure. So, like I mentioned, we have a lot of customers on AWS of all segments. And the cool thing is, because it's one cloud, all these customers and all their stringent security requirements and all their regulations basically drive a very secure AWS cloud. So, like I mentioned, we have customers in the financial industry, in healthcare, in government as well. They are very security conscious. They have strong requirements, and the AWS cloud enables these customers to be secure and compliant. The cool thing is, this benefits everybody. So these are not one-offs for just one financial customer. It's one cloud, it's shared, right? So all the security is shared as well, security features as well. We can say that we are secure, we can say we operate our environments in a secure way, we have documented everything, so you can read our white papers, how we operate our facilities, how we secure, how we apply physical controls, logical controls, everything's documented anyway. That would just be you trusting us. So we have external auditors, independent organizations, assessing us pretty frequently. It depends on the certification, whether it's twice a year, that we indeed comply with that regulation. So these are organizations that are experts in their industry and experts in cloud, and they certify that we do indeed comply. If you want more information on this, then you can go to the security page. You will find these certifications, and they are sort of arranged, whether they are global certifications, like you see here, or whether they are more like region or country specific, like the US, or whether they are applied to the UK. But you will find that we have most of the certifications that will cover any regulation actually in Europe. So one of the examples is Philips. Philips puts patient records into the cloud, into AWS. So definitely needs to comply with HIPAA, for example. That's really a lot. So this is also a sort of a scalability example. They store 15 petabytes. They started out actually with 15 petabytes of data. They simply could not store on premises. And they grow with approximately 1 petabyte a month. So one's the scalability thing, the other is being secure and being compliant with their required regulations. So the third one is a move to serverless applications. What do I mean with serverless? So the computing options that you have traditionally, think of your data center, but also in AWS, is that you develop your solutions and run them in a virtual machine. So without going into details, if you know virtual machine, think of a computer. So that's the unit of scale. It holds an operating system, and that's where you deploy your solutions into. You also have the option to deploy your applications using containers. So think of containerization, think of Docker containers, probably heard of that, with all the benefits, at least for developers, to develop and run solutions within the container, and that the solution will run everywhere where Docker is supported. And then there's the notion of serverless, which actually means there are no servers anymore to manage for your application. When you deploy your solution on an operating system, for example, a web app, onto a web service, you're still deploying to a server, to an operating system, which means that you need to manage them as well. It's similar to containers. Although it's an abstraction, you're still deploying to servers. With serverless, you deploy code. You're only deploying code. And so the unit of scale is just a function. And we will execute your function based on an event. So it's an event-driven model. The cool thing here is so it abstracts the runtime. So you're not concerned with underlying hardware. You're no longer concerned with operating systems whatsoever. So sometimes the question comes, what do I choose? So should I go all for serverless? Should I go in containers? What should I do? And it's not a one thing. It's not a one-size-fits-all solution. It's just it's another delivery mechanism, another way to implement a lot of your code that is just sitting there in idle servers, waiting for something to happen, and then it executes. You probably already understand that that's costly, right? If you have infrastructure just sitting there for the moment that something needs to happen, and then your code executes, and it is pretty infrequent, then it means that you're wasting money on your resources. So what do I choose? So if you really need full control on the whole environment in a virtual machine, then you select a virtual machine. You need to configure the machine, the storage, networking, operating system aspects. If you don't need that, then you can basically focus on your application, and you want to make sure that your application runs everywhere based on a Docker container, then you select containers. If you just want to run your code when it's needed, think of events, changes. I have a couple of examples of that coming up. Then that's where you go for serverless. So we have a service for this. I'll not go into the details. I can do that if you visit the booth. It's called Lambda. It enables you to run in a serverless fashion. You simply deploy your code. That's all you do. So think of changes that happen in the environment. Think of changes in your application. It could be a change in a database. And a change in a database could trigger code to execute. So I think there are limitless amounts of scenarios. And that's what we've seen since we announced it, actually 2 years ago, that there's a huge take-up of this model that enables developers just to develop their code, just deploy the code, and then they're done with it. The cool thing is, we will take care of scaling. So you don't have to manage anything anymore. We will scale up. So when there's more events happening, we will just scale it, and you don't pay for otherwise servers that are just mainly, for the most part of their lifetime, are sitting idle, waiting for something to happen, and then executing code. So it's also definitely a cost optimization aspect as well. So one of the customer cases is Netflix, for example. Netflix does a lot of video encoding. So when a file comes in and it's dropped in our object store, something happens. Something needs to happen. So think of all the form factors. So a video needs to be streamed, maybe to your TV, to your game console, to your phone. They all have apps for that. So different formats as well are required of movies, for example, to stream. So when they get this from the media companies, they upload it into this container. And when they upload it, a function gets triggered to encode or transcode these files. They do this as well, for example, just for cross-region replication. So if they want to replicate data from one region to the other, something changes in one region, then they automatically replicate the changes out to another region. So I think the last thing I'd like to go into is definitely something that happens with typically larger organizations, and that's all about going into microservices. So think of an application, a traditional application, I would say, whether it's on premises and maybe when it's forklifted into the cloud. A monolithic application is an application that is just single deployed, single managed. It contains a lot of functions, but it's being developed and deployed as a single thing. So think of there's one code base. There are multiple teams, multiple disciplines, but they all are responsible for a part of the functionality of the application. And this can be quite problematic when the application grows. So when there's more features, more functionality added all the time, then it becomes quite a large thing. And when things fail, and the larger applications become, and the more changes happen to applications, the more things will fail, means that your application may fail. It may introduce more downtime as well. So larger web applications are being re-architected to cope with these situations. So they move away from monolithic apps, and they just realize what the unique functions are in their application They search for these components or functions, and they will split it up and create multiple services out of that. So microservices is a service-oriented architecture, but much more geared towards really focusing on the key features of an application. Think of a login function, think of a database function, the many other functions obviously, but these are just some easy ones that can scale independently. If you take them out of the application, you create separate services out of them. So if the demand increases and a lot of people are logging on, then if it's still a monolithic application and you were somehow able to scale it, then the whole environment needs to scale. But if it's just a login action that needs to scale, then you can now, by taking these apart, creating separate services out of them, scale these independently. So a microservices architecture enables you to do this. You can test them individually. You have teams that can design and develop and actually operate them independently. So it gives you a lot more speed as well. So if you need to introduce new features in your application, then you can do that much more quickly because you are autonomous. So when Amazon grew, Amazon.com, so the retailer, so when it grew from obviously the first years into a very, very large web application, we ran actually into the same, that it was still a monolithic thing. And it grew and it grew, and we needed more features, more catalogs, more users, but many, many more features in the Amazon application. So we needed to re-architect the whole thing to be microservices oriented. So what we say actually within Amazon.com is when you develop it, you also run it. So if you build it, you run it. That's the statement. Which means that now a team that's responsible for a specific service, a specific feature, is responsible for the design, the development, the deployment, and the operation. So putting it into operate as well. So they run it as well. So you get independent teams responsible for the full life cycle, from design to operation as well, and upgrades the whole life cycle of that feature. So it results in an enormous amount of speed, and it enables to innovate much more quickly, because you're not dependent on everybody. So if we all here were just developers in one team, then making changes on a specific feature that you wanted to do really has impact to everybody. So by separating them out, you are independent. You can scale independently, you can innovate, you can also fail independently and not taking the whole application down, because separate services can fail separately. So what this means, just to have a slide with numbers on that when it comes to the deployments and the speed that it enabled. This applies to Netflix as well. I mean, not the numbers, but the flexibility. Is that we do a lot of deployments. Think of this, approximately 12 seconds, the mean time between deployments. So we do 5 deployments, let's say 5 deployments in a minute. So there are 300 in an hour. So when we peak, we have approximately 1,000 deployments in an hour. So this is what it enables if you take things apart. And this happens all the time at the Amazon.com retail page. This happens at AWS as well. We work in a similar way, so we can easily change things within services. We can add features without endangering the whole service or the whole product. And we can innovate much more quickly. So this is also an argument and also the reason why we're able to innovate so quickly with our services in the platform. So I realized that for many people, the AWS cloud is still maybe a bit of vague as what does it actually contain? What do we add? So where's the link with Mendix for one thing? After the keynote, I think it's clear to a lot of people what the link is. If you want to know more, then I would say go to the Mendix booth when it comes from the Mendix perspective. If you want to learn more about what's actually all there in AWS Web Services that you can integrate with, because you can leverage the connector kit and create your integration as well to everything that's not there, then just come and visit us at the AWS booth. We are at the entrance of the expo, and we'd be happy then to explain what's there and what the platform can add to the applications you develop. So with that, I'm done with my presentation. So if there's any questions, please come up. If you want more explanation, to see a bit more about AWS, then please visit us at the AWS booth. Thank you.